Welcome to Lesson 5 of Introduction to Python. In today's lesson, we're going to review two main ideas, collections and functions. So we mentioned in previous lessons that a variable is a part of Python that can contain one item. We also mentioned how a list can basically contain multiple items and values. In Python, a collection of items, or a collection, is any type of structure that allows you to contain multiple items, just like a list. So anything that contains multiple values counts as a collection. There are two main categories when looking at collections. The first is a mutable collection. The idea of a mutable collection is that a single element after creating this collection can be changed. So an example of a mutable collection is a list, because after we create this list, we can change a value in a list by reassigning it to the index. But the other type of collection is immutable. What it means is that single elements cannot be changed after creation. So let's look at a brief review of a list. The syntax of a list is denoted in square brackets. So we start a square bracket and then we simply put the actual value in here, followed by a comma, and then the next couple values, so on until we put the ending square bracket. So as mentioned before, a list is mutable. They allow duplicates. What this means is that in our values, we could have hello here, but also hello here. It would still be the same list, and these would be different values, because they have different indexes. So the fact that we have indexing means that every value corresponds to an index, and every index corresponds to a value. A cool thing we can do is called negative indexing. So just like how when we use positive indexes, we start from 0 and we go on up. Negative indexing finds the value at the index from the end to the start. So the value at -1 would be the last element of the list, no matter how long the list is. And then when we go backwards, -2 would be the element 1 away from the end, and then -3 would be 2 away from the end, and so on and so forth. This way we can give a value of a negative value and a positive value to every element in the list. So what other types of collections are there? One main type of collection that we can look at is called a tuple. The idea of a tuple is that the syntax, unlike lists, is a parentheses instead of square brackets. And just like lists, it allows duplicates and indexing. Tuples are pretty similar to lists, except for one point where they're immutable, meaning that you can't actually change individual values afterward. So in this example, we set our tuple to be high, 3, and 4. And if we were to print it, we have our tuple. And note that we can still call these indexes and get the value. We just can't change them. Next is a set. So the syntax for set is that we use these curly brackets instead. And sets are mutable, so we can add elements or we can change elements afterward. The thing that makes sets really useful is that it doesn't allow duplicates. So when we create a set with duplicates, no matter what, sets will always be arranged from least to greatest, and it will never have duplicates. So if we set our set to be this value, these 4s will correspond. These 4s will correspond to a single value here. And when we print it, it'll have all of these values, no duplicates, arranged from least to greatest. Because of this, there is no indexing in sets. Sets have two main operations that we'll look at today. The first one is a union, and then the second one is an intersection. Just like how we mentioned in binary operations, these commands work just like OR and AND. So the union, which is a single line, basically says anything that is in OR. So if we were to get this set or this set, it would take all of the values that are in both sets. And as you can see, since there are no duplicates, it would return 1, 2, 3, 5. And then the AND here, or intersection, works just like binary AND, meaning that it'll only return the values that are in both set 1 and set 2. In this case, that's 3 and 5, so it will return 3, 5. As we can see, we can denote this as OR, meaning that it'll take all of these values, and then we can denote this as AND, meaning it'll take only the values that both of these sets have in common. So the final collection we're going to be looking at is called a dictionary. And dictionaries are kind of different from the other collections for one main way. So again, we use curly brackets for dictionaries. However, not only do we have indexes for dictionaries where we assign a value 0, 1, 2, etc., we also have these things called keys and values. Let's say we have a chest full of items, and each one of these items is different and unique, and we don't know which one we're looking for. Well, one way to tell ourselves which one we're looking for is to assign each one a little tag or a key. So in dictionaries, we have a key that is assigned to a value, and these keys, when called, will be able to return the value. So we would put dictionary name and then square brackets, the key name and square brackets, and we would return the value. Dictionaries are mutable, but they don't allow duplicates. In addition to the keys and values, they also have indexing. So these keys don't necessarily need to be numbers. Both the value of the key and the value of the value can be any of the different types. If we look at our example of a dictionary here, in this case, we have integers for our key and a string for our value. So if we were to print mydict1, it would return blue. But if we print the dictionary as a whole, we get this list of keys and values. Let's look at a review of our total collections. So again, we have our list, and not only is it ordered, mutable, it's also able to be indexed and allows duplicate members. Again, the main difference between a list and a tuple is that a tuple can't change individual items and are therefore not mutable. A set is not ordered because it starts from the least to greatest, and it also doesn't have indexes. We can add items, and it is mutable, but there are no duplicate members, which makes it particularly useful. The final one, dictionaries, they're not ordered, but they do have indexes, and we can add items to our dictionaries. However, we can't have duplicate items in our dictionary. Now let's look at the second main idea, functions. What a function is, it's a group of related statements that executes only when called. So in math, we also have functions, and they're usually denoted as fx equals some other value. In Python, what it basically is splitting up our code, and this code will only execute if we call the function. So it's like assigning a name to a list of commands, and then once we want to run this list of commands, we have to call this name. The main syntax of a function can be split into two parts. So we have the starting statement, which is define def. We use the word def. It's always this keyword. And then we put the function name. And this has to be unique. It's just like naming a variable. Then in parentheses, we put what's called a parameter. Now, parameters are optional, but when we do put them, it's basically creating variable names that we can use in this function and this function only. So we will have like x, another variable, or a list, and we can put all these parameters in here, and these parameters will be used in this code. The next part is more of the body. So we have the statements run, and then these are only executed when we run this function. And then at the very end, we can do this thing called returning, where if we run this function, we're giving this value to this. So let's say I assign a value of x to whatever this is. X will be the value that this returns. The thing with functions is that it's useful when you don't want to repeat code. So we could put our function name, and then we can put our different parameters. And we can run this function as many times as we want, with different parameters, which is why it's useful. A great example of this function is this one. So we have the def statement, and then our function name is print animal. In this case, our parameter is animal name. So for the actual syntax, we'll put the variable name here. So we have if animal name is equal to cat. So if whatever is put in here is this string, we'll return the value of 1, or else we'll return the value of 0. So the important thing to know about functions is that as soon as we return, we exit out of the function. So if we go in here and we return here, we don't run anything else. We'll just return this value and exit the function. So let's say we run and call this function the first time with the string cat. It'll go in, and in this case, animal name is given the value of cat. And since this statement is true, we will return 1. So this will print out 1. But then when we run it again with the value of 2, what happens is the value of animal name is now 2 instead of cat. So this is false and will return 0, meaning that this will return 1 and this one 0. Now let's look at some final examples and problems. So here we have our function named hello, and again, we don't need parameters. So what we can do is we can create this string called hello world, and we'll just print it out. So when we run this function, all we have to do is basically give the name and then the parameters. And since in this case there are no parameters, all we have to do is give the name and then the parentheses. So we'll go in and then we'll print greet string. And since the greet string is hello, comma, space world, we'll basically just print hello, comma, space world. This code does the same thing, but it returns it in a different way. So in this case, we're actually printing out this function, or we're printing out whatever this returns. So when we create hello, this time we're going to take a parameter, and in this case, it's going to be name. So we create greet string, and then we put hello, comma, plus name. And since our value of name in this run of the function is world, we plug in world here, so it will again return hello, comma, world. Once it returns it, it'll basically turn into print whatever this returned. So it'll print greet string, which is hello plus world. So again, it will print hello, world. What about this one? What would this print? This value is actually going to print from here, this is -1, banana, because we start from this is index 0, this is index 1, and this is index 2. But since this is negative, we start at the end here as orange as -1, and then banana as -2. So it's going to print out the word banana. Now, what type is fruits? What type of collection is it? So we see these curly brackets, and that means it could either be a set or a dictionary. However, since we don't have a key and there are no colons, the value of fruits is actually going to be a set. So if we go for A in fruits, print A, we're just going to print out these strings, and the type of in fruits is a set. What about this version of fruits? In this case, we have parentheses, which denotes that this is actually going to be a tuple. So fruits is a tuple. What about this one? Okay, so again, fruits is going to be a set, and we're going to set the value of A as the string carrot. So we're going to go if A is in fruits, we print true. And since this string is not in this set, we're going to go and print false. So that's the end of lesson 5. Thank you for watching.